Hey everyone, welcome to Singularity today. I'm Adam Infinity, and today we're diving into some incredible recent breakthroughs in artificial intelligence. These researchers are pushing the boundaries of what AI can do, from building robots that can reason and explain themselves to creating large language models that can process long pieces of text and even generate captions for images. Get ready to be amazed as we explore how these advancements are shaping the future of AI and its potential to revolutionize our world. In the research titled DualAD, Dual Layer Planning for Reasoning in Autonomous Driving, the authors propose a new framework for autonomous driving systems that tries to mimic human reasoning. This framework, called DualAD, has two layers: a simple rule-based planner for routine driving tasks, and a more complex layer that uses a large language model to understand and react to more challenging situations. The idea is that when a simple planner can't handle a situation, the more complex layer steps in to help, just like humans would use their reasoning skills in a difficult situation. The researchers found that DualAD performed significantly better than systems that only used the simple planner. They also showed that the text encoder, which turns driving situations into words, helps the language model understand the situation better. This research suggests that incorporating large language models into autonomous driving systems could lead to more robust and safer systems. This could be used in a variety of ways, including self-driving cars, delivery robots, and even drones. In the research titled Explaining, the authors explore the challenges of making artificial intelligence systems understandable to humans, especially in high-stakes situations. They argue that traditional machine learning models are often like black boxes, making it difficult to understand why they make certain decisions. This lack of transparency can be problematic when relying on AI for critical tasks. The research suggests that we need a new approach to AI development, one that combines knowledge-based systems with machine learning. This hybrid approach aims to create cognitive agents that can explain their actions and reasoning to humans. Imagine having a robot assistant that not only helps you with tasks, but can also tell you why it's taking those actions. This research proposes the development of these explainable agents, which can act as partners to humans in critical tasks, ultimately leading to more trustworthy and accountable AI systems. The impact of this research could be significant, as it could lead to the development of AI systems that are more transparent, understandable, and reliable, especially in domains like healthcare, finance, and autonomous vehicles. In the research titled Revisit Anything, Visual Place Recognition via Image Segment Retrieval, the authors address the problem of recognizing a place from different viewpoints, which is a challenge for robots navigating in the real world. They propose a new approach called SegVLAD, which focuses on retrieving meaningful image segments instead of the entire image. This approach improves the accuracy of recognizing places compared to traditional methods. The research concludes that SegVLAD sets a new state-of-the-art in place recognition. This research can have a significant impact on robotic navigation, virtual reality, and other applications where recognizing places is crucial. For example, robots could use SegVLAD to navigate complex environments or to identify familiar objects in a scene. In the research titled Harmonic, Cognitive, and Control Collaboration in Human-Robotic Teams, the authors propose a novel approach to multi-robot planning and collaboration. They introduce a cognitive strategy that enables robots to think for themselves, communicate using natural language, and explain their actions to humans. This strategy is implemented in a system called Harmonic which allows robots with different abilities to work together seamlessly in a team. The research demonstrates that this cognitive approach is crucial for successful human-robot teaming, particularly in complex real-world scenarios. The researchers conducted simulations involving a search task where a human collaborated with a ground vehicle and a drone. The findings highlight the importance of robots being able to understand plans, goals, and attitudes, and explain their decisions. This research could potentially have significant impact on fields like search and rescue, disaster relief, and even everyday tasks such as home automation. Imagine robots assisting firefighters by communicating their strategies and explaining their actions, or collaborating with construction workers on building complex structures. These advancements in human-robot collaboration could lead to increased efficiency, safety, and effectiveness in various industries. In the research titled IFCap, Image-like Retrieval and Frequency-Based Entity Filtering for Zero-Shot Captioning, the authors tackle the challenge of generating captions for images without relying on paired image text data for training. This is crucial because relying solely on text data during training can lead to a disconnect between the training process and the actual task of captioning images. To bridge this gap, IFCap introduces a clever method called image-like retrieval, which aligns textual features with visually relevant features. This alignment helps the model understand the visual context better. Furthermore, IFCap incorporates a fusion module that combines retrieved captions with input features to improve the accuracy of generated captions. Additionally, the frequency-based entity filtering technique refines the captions by focusing on the most relevant entities, making them even more accurate and descriptive. The researchers tested IFCap extensively and found it outperformed existing methods, achieving remarkable results in both image and video captioning. This research has significant implications for various applications like automatic image description for visually impaired individuals, content creation tools for social media, and image search engines. Imagine a scenario where you upload a picture of a sunset and an AI automatically generates a beautiful caption describing the scene. This is just one example of the potential use cases of IFCap. The research's success in zero-shot captioning opens up possibilities for creating systems that can understand and interpret visual content without explicit training on paired image text data, paving the way for more advanced and intuitive AI applications in the future. In the research titled Harmonic, a framework for explanatory cognitive robots, the authors introduce a framework for creating robots that can think and make decisions like humans, communicate naturally, and explain their reasoning. This framework allows robots to work seamlessly with humans as trusted teammates. It divides the robot's tasks into two levels: strategic thinking and planning, and tactical physical actions. The researchers tested Harmonic on a simulated robot searching for objects in a virtual environment, demonstrating its potential. This research could lead to robots that are more capable and trustworthy partners in a variety of fields such as search and rescue, manufacturing, and healthcare. For example, a robot equipped with Harmonic could be used in disaster relief efforts, explaining its actions to rescue workers and helping them make informed decisions. In the research titled Compositional Hardness of Code in Large Language Models, a probabilistic perspective, researchers explore the challenges of large language models in solving complex tasks that involve multiple steps or subtasks. They find that ELMs struggle to perform these subtasks efficiently when they're all crammed within the model's limited context window, like trying to fit a whole puzzle together in a tiny box. This is called in-context hardness of compositions. The study reveals that distributing these subtasks across multiple elms, like having different experts work on different puzzle pieces, dramatically improves the model's ability to solve the overall problem, especially for longer and more complex solutions. This research highlights the potential of using a multi-agent system of elms for more complex tasks. Imagine you need to build a complex system like a car. It would be much easier and efficient to have different teams focusing on the engine, the brakes, and the body rather than one person trying to manage everything at once. This approach could improve the accuracy and efficiency of elms in tasks like code generation, software development, and even scientific discovery. In the research titled An Adversarial Perspective on Machine Unlearning for AI Safety, the researchers investigated the effectiveness of unlearning methods in removing dangerous capabilities from large language models. They found that unlearning methods, which aim to remove hazardous knowledge from models, can be bypassed by adversaries. This is similar to trying to remove dangerous information from a computer, but finding ways to still access that information. The research suggests that current unlearning methods may not be as effective as initially believed, and their advantages over safety training may be questionable. This finding is significant as it highlights the need for more robust and effective unlearning techniques to ensure the safety of large language models. The research can be helpful in guiding future efforts to develop more secure and reliable AI systems. In the research titled Transferring Disentangled Representations, Bridging the Gap Between Synthetic and Real Images, researchers explore the possibility of using synthetic data to create general-purpose disentangled representations that can be applied to real images. They investigate how well these representations transfer to real images and what properties of disentanglement remain after the transfer. The research found that it's possible to transfer some level of disentanglement from synthetic to real data, and that this transfer can be effective. This finding is important because it suggests that we can use synthetic data to learn representations that are useful for real-world applications. For example, imagine you are trying to build a system that can recognize different types of objects in images. You could use synthetic data to learn a disentangled representation of the objects, and then transfer this representation to real images. This would allow your system to recognize the objects in real images more accurately. The study also introduces a new metric to measure the quality of disentanglement. This metric is based on interventions, which are changes that are made to the input data. This allows researchers to better understand how the representation is capturing the different factors that contribute to the data. The research opens up new possibilities for using synthetic data in real-world applications, particularly in areas like object recognition, image generation, and data analysis. In role online long context processing with role reinforcement learning for distinct elms in their optimal roles, the researchers tackle the challenge of handling really long pieces of text, like news articles or live shopping streams, with large language models. They've come up with a new way to process this information called online long context processing, OLP. Imagine you have a whole bunch of different elms, each with strengths and weaknesses. The researchers have developed a system called role reinforcement learning, role that automatically decides which LM is best for a particular task within the OLP pipeline. Think of it like having a team of specialists, each expert in their own field, working together to get the job done. In their experiments, they found that OLF with role works really well, achieving high accuracy and saving a lot of money by using the right elm, for each task. This research could be super useful in areas like news reporting, live e-commerce, and even online video platforms where long text and fast processing are important. All right, folks. That's it for this week's deep dive into the world of artificial intelligence. I hope you enjoyed this mind-bending journey through the latest breakthroughs in AI. Remember, you can check out these research papers yourself, and if you do, be sure to come back and share your thoughts in the comments. And remember, if you're enjoying this content, don't forget to hit that like button, subscribe to my channel, and ring that notification bell to stay up to date on all the amazing things happening in the world of artificial intelligence. Oh, and one more thing. This whole video was generated by AI. Yep, no humans were involved in creating this analysis. So enjoy your free time, knowing that the machines are working hard to bring you the latest and greatest in artificial intelligence. Until next time, keep learning, keep exploring, and remember, the singularity is coming, eventually,